Hi guys, so today we are going to kind of recap what we did before we were out of the classroom, which was probability. So I'm going to go over this review, and after we go over this, then you'll be able to complete the MathSpace assignment and your eCart test. So what you need to do is go ahead and have a piece of paper next to you and a pencil, pen, and a calculator or Desmos if you'd like. All right, and so what you're going to do is you're going to take notes along with me, just as if we were in class, and then you're going to upload this so you can get credit for today. Attendance was one part, but the second part is that you take the notes. I do not expect you guys to write every single word that I have on my paper. If you want to write number one and then just show the work and the answer as I write it, that's perfectly fine, as long as I could see that you are taking notes. I will post this also on Blackboard and Google Classroom. You can print this paper out if you'd like, but it is not required by any means. You can just use a blank sheet of paper. All right, so we are starting with topic one, which is our fundamental counting principles. This basically means like what are the max number of options I could have based on a scenario. So number one, how many ways can 6 different books be arranged on a shelf? So we talked about this in class. If we did this by hand, we would take a book and we would put like let's say there's different colors. So like the red book would be first and then so on and so on. That red book could also be second. It could also be third. So what we're going to do is have 6 factorial. Because it says how many different ways can 6 books be arranged on a shelf. All right, if you're using a regular calculator, you can certainly do 6 times 5 times 4 times 3 times 2 times 1, because that's how we do factorial. Or you can grab Desmos. I'm showing you my phone. All right, and my screen's kind of bright. But you could just type in 6, and then you can type in exclamation point. Okay, so you get 720. Either way works. If you don't have Desmos downloaded, go ahead and do that ASAP. We use it a lot in class, but I just want to make sure that you guys have it. All right, number 2, you have 4 tops, 3 pants, and 2 jackets. How many different combinations can you make? So we're going to multiply each of my categories. I have 4 tops, 3 pants, and 2 jackets. And we don't need to use Desmos for this. 4 times 3 is 12. 12 times 2 is 24. Zoom in just a little bit more. All right, number 3, let's say you have a password with 2 letters and 3 digits. How many different options can you have? Well, I know there are 26 letters in the alphabet. So if I have 2 letters, I can have any 26 of those letters times any 26 of those letters again. And 3 digits. So from numbers 0 to 9, okay, so you can have 9 digits or 9 digits or 9 digits. So what I just did, the 2 letters here are represented by 26 and 26. And the 3 digits are represented by 9, 9, and 9, because we can have 9 digits. If you count from 0 all the way up, there we are. Hold on one second. All right, so I made a mistake here, and we're just gonna fix it. Because I was thinking that this said like without the number 0 or something, but if we were to count 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, that's 10 digits, not 9. So we're going to change that 9 to a 10. We're going to have 10 digits. And you just have to be careful because sometimes on your assessments and on MathSpace, it may say without using the number 0 or without using the number 9. In that case, you would take that out, depending on which numbers they say. All right, so if I were to multiply this, I'm going to grab Desmos so you can see it. And I'm going to do 26 times 26 times 10 times 10 times 10. So this number here, 676,000 options. That is my answer. Sorry about the little hiccup. Hope you guys were able to correct that. All right, topic 2, independent and dependent events. So my statement says, suppose that you have a bag of 14 marbles, 2 are black, 3 are red, 4 are yellow, and 5 are green. Once a marble is chosen, it is replaced. Find the probability of the following. All right, so what's important here is this right here. They're telling you it is replaced, okay? So that means if there's a bag of marbles and you're pulling one out, you're actually putting it back in each time after you pull it. All right, so this P here stands for probability. So what is the probability of not getting green and then getting red? Okay, so let's see how many green there are. There are 5 green. So it says we're not getting green. So 14 minus 5, that means there are 9 different options out of 14. And we're going to multiply because now we're going to put that marble back and we're going to see the probability of getting a red. Well, there are 3 red. So 3 out of the total, which is 14. All right, and if you were to do this in your Desmos calculator, you could do 9 divided by 14, scroll over, times 3 divided by 14. You're going to get this long decimal here. Just hit this answer here. This little button over here lets you simplify it. So that becomes 27 over 196. And that is my answer. All right, number 2. What is the probability of getting a yellow and then a yellow again? All right, so there are 4 yellows out of 14. And let's say I put that one back and then I can still get 4 yellows out of 14. All right, so if you put this into Desmos and simplify, you get 4 over 49. All right, so now it says suppose that you have the same scenario, the same 14 marbles, the same colors, but this time it is not replaced. Which means instead of having 14 total marbles, every time I pull one out, I'm going to have 1 less. All right, so the probability of not getting green, so that means there's 9 other colors out of 14, and then not getting red. So that's 3 out of 13. I'm subtracting 1 because I didn't put whatever marble I chose. I didn't put that back. It is not replaced. Okay, so if you type that into your calculator, I'll do it here. 9 divided by 14, slide over, times 3 divided by 13, and then I'm going to simplify it, and I get 27 over 182. So as you see, numbers 1 and 3 have the same exact scenario besides one is replaced and one is not. That's the difference between independent and dependent events. And so you have a better chance when it is not replaced. All right, number 4, you choose a yellow. There are 4 yellows out of 14. And then getting yellow again. So that is going to be 3 out of 13 because I could have chosen a yellow when I picked it. All right, if you put this into Desmos and then simplify, you'll get 6 over 91. All right, let's move on to the last section. Permutations and combinations. All right, so number 1 says, find the number of ways to purchase 4 different kinds of juices from a selection of 12 different juices. So in this case, if I had to choose between permutations and combination, this would be a combination. Order does not matter. Okay, so that's why it's a combination. I'm just choosing. So I'm going to put this big C here. All right, and then I'm looking for the number that goes first is the number that is my total. So I'm trying to choose 4 different kinds of juices from a selection of 12 total. So I'm going to do 12, choose 4. We did this in the TI calculator, but clearly you guys may not have that at home. So on Desmos, this is how you do it. We are going to go to functions. All right, and when you go to functions, go to the stats, and you're going to hit NCR because we're doing combination. And I have 12 total. My comma's over here, and I'm choosing 4. So my total there is 495. 495 different kinds of juices. And if you guys remember when we did this in class on the board, we can write this 12C4. This is the same thing. These two things are the exact same. It's just written a little bit differently. All right, number 2, 12 Herndon swimmers are trying out for the regional swim team. The best 4 swimmers make the team. How many ways can the 4 swimmers be chosen? Sorry, I didn't update my sentence. And does order matter? All right, so does order matter? Yes, because we're talking about the best. When it says the best, that means that something is going to count to tell us that, how we're going to put them in order. Okay, so order does matter. So this would be a permutation. All right, so here's my equation or my expression. I have a permutation. My total number of swimmers, I have 12, and only the best 4 can make the regional swim team. So that is 12P4. So let's go ahead and go to Desmos. I'm going to do the same thing. Go to functions, go to stat. Instead of picking NCR, I'm picking NPR because that tells me I have permutation. 12, 4. And my answer is 11,880 options. All right, so this last part here is just you practicing. So you can do this on your own, but we can use our Desmos, and if you do 7C4, you should get 35. And if you do number 6, 6P6, you should get 720. To complete your notes, I want you guys to do these 4 on your own. Make sure that you put those answers on your notes so I can see it once you turn it in. All right, that's it. See you guys.